This is an unholy abomination. It's the Razer Blade 18. It's 18 inches because it's got a mobile 5090 in it. It's not a desktop 5090. It is a laptop 5090. 24 gigs of VRAM, not 32. That's the big change. There's some changes in the ROPS and performance and some other things, but it is very power efficient. But this could scarcely be called a laptop. I mean, really? Okay, let's unbox it. I'm trying to do this non-destructively because this is on loan from Razer. I have to send this back. It still says for gamers, by gamers. I mean, with a 5090, this definitely qualifies as a gaming laptop, but let's be honest, Razer thinks that people are going to buy it for AI and work. And maybe that makes sense. This is a dual fan design. It's designed to pull air from the bottom and exhaust it out the back. It is remarkably thin, but it does have features on the bottom that make it a little thicker than you might expect. We do have a full-size Ethernet port. Ooh, I'll be curious to see how fast that is. This is a 400-watt power brick. The power brick itself uses a standard PC power cord, and the connector is Razer's sort of 3-pin design that's not really new. Now, this is a 16:10 aspect ratio display. It is 4K, full-size keyboard with a numeric keypad. It is RGB. Has a built-in webcam with a privacy shield so you can slide it closed. But it still has the Windows Hello camera so you can still see it in infrared. The privacy filter is really interesting because if you block the infrared, it still works. If you block, I have not slid the shutter, but if you just block the camera, it stops emitting the infrared and turns off the infrared camera, which I think is very interesting. To get at the inside is just 12 T5 Torx screws. It kind of hinges up from the back, and you can see that we've got a lot of thick thermal pads here. This one's actually just for sound, but our M.2s definitely have some thermal pads that connect to the bottom aluminum part of the case. Now, my configuration just came with a single M.2, but you do have an open M.2 port. It almost looks like mine has something missing, but really, it's fine. The upgradable memory is just under the foil heatsink thingy here. In case you're wondering about the BIOS on this, it's a pretty bare bones BIOS, but it does let you configure some things. You can configure battery protection, so it'll only charge to 80%. You can also configure the native display to be 1920 by 1200 instead of 3840. There are some secure boot options if you need to mess with secure boot or you're doing something funky with Linux. It seemed like it was going to have an option to boot from the network, the built-in wired port, but that didn't work for me. I wasn't able to do PXE booting. I'm not sure why. I didn't really try super hard, but just be aware of it. It does also have some options around CPU configuration and undervolting. Like, undervolting is disabled in the BIOS on this, so if you're into undervolting to try to squeeze some more efficiency out, you're going to have to go into the BIOS and toggle that setting. It also has trusted computing setting, Intel VMD. You could run VMD, some kind of like RAID 0 off of your M.2, probably, maybe. I mean, it's got the BIOS option for it. Also, USB charging. That's all disabled, and the battery protection is disabled by default as well. Smell that? That's the sound of this thing having been on for the better part of 2 days, running AI things as fast as it possibly could. Oh boy, it does get toasty. Using our thermal camera, the hottest hotspot on it was about 102 degrees Fahrenheit. So actually not terrible. At the wall, it can spike upwards over 300 watts, but it maintains a power draw of around 280, 290 watts, something like that, give or take. But I'm getting a little ahead of myself. I want to put Linux on this thing, but I also want to make sure that I don't break the performance or otherwise destroy what otherwise might be a beautiful, beautiful performance from such a Brobdingnagian machine. On this side, in addition to power, we've got our 2.5 gig wired Ethernet port. I really wish they could have splurged for like 5 or 10 gigabit. That Realtek 10 gigabit chipset is pretty inexpensive. You could do USB 10 gigabit, and that works. And then you get your headphone microphone combination jack on the side. On the other side, we have a full-size SD card slot, another USB Type A port, a Type C port, full-size HDMI, and a Kensington lock port. Also, the sound system on this laptop is kind of ridiculous. It starts out at 6 speakers. It sounds really good. It has an enormous touchpad, and the touchpad is a joy to use on Windows. There are 12 Torx screws on the bottom. but otherwise it's pretty easy to get into the bottom, and it's pretty good for upgradability. Razer says they can go to 96 gigabytes of memory. In reality, they can go to 128 gigabytes of memory. I'll show you more about that in a second. This thing is hefty at just over 7 pounds without the power brick. Now our display and our webcam, Windows Hello, built-in webcam quality, it's okay. This is what it looks like when we're recording from the built-in webcam. It's pretty good quality, and this is the audio. Now, this is also really like an HDR situation because I'm trying to blind the sensor, but it's not working. I put more thought into that, so this should be a pretty reasonable experience as far as laptop cameras go. 240 hertz natively, 480 hertz if you run at half resolution. Our native resolution here is 3840 by 2400. That's why we got some black bars on our 3840 by 2160 external monitor. Let's talk about our Windows performance and our Windows benchmarks. I decided to compare it against a Ryzen 9 9900X and the Core Ultra 7 270K+. Those are both desktop chips. It's basically a portable desktop. I think if you were splashing out this much money on this much machine, it's like, do I want a portable machine, like a luggable machine that doesn't run from battery? Would this actually work? There's a couple things we're going to talk about in the thermals and power section, but just for performance, just for fun. So 8 to 64, 84 gigabytes per second, 94 gigabytes per second for my Razer Blade 18 versus 105 gigabytes per second for the Core 70K+. This is a fantastic result for a portable machine. Would have liked to have lower latency, 100 nanoseconds, but that is the stock memory configuration. I can beat that with a 96 gig kit of memory, but I can't beat it with my 128 gig kit of memory, because when you go 128 gig, the performance is not quite as good, at least for the 2x64 gig kit that I have. And I think that's why Razer doesn't recommend 2x64. 2x48 in there as one of their supported configurations, yes. And this configuration that we're running with, I think is like $5,500 in that ballpark. That was the shipping insurance. But I noticed that the configurations start from $3,400 and go on up. So just depends. Our CPU-Z performance, our single core score is basically identical to a desktop system. And our multi-core score is pretty similar as well. I mean, 16,000 versus 12,000 on a Ryzen 9 9900X. Hilariously, you can get into the power draw of the 9900X, and it's not that much different, even though this is a portable CPU. The vapor chamber cooling design in this Razer Blade 18, I think, is probably one of the most state-of-the-art things about it. It's designed for just over 100 watts of heat dissipation on the CPU side of things and 200-ish watts of heat dissipation on the GPU side of things, thereabouts. Like total heat output, 280 watts of heat dissipation in the Razer specs. And from looking at the power draw at the wall while I'm running stress tests, that seems to be in line with just, the back of the envelope math, looking at the power utilization. Now, it can spike well over 280 watts, but when we're talking about that long sustained load overnight, 280 watts. Cinebench 2023, about 2,300 and a 37,000 multi-core score, very respectable. Cinebench 24, 140 single core, again, perfectly in line with all of our other CPUs, and our multi-core score is very good at just over 2,000. So Geekbench 6, single core score is basically identical. Our multi-core score is very similar across the board. Our OpenCL performance is about 250,000, and our Vulkan performance is about 22,000, give or take. Really not any unexpected results in that result set. Cyberpunk 2077, because it's a gaming laptop. If you're just buying this for gaming, okay, but I hope you're doing more with it than just gaming. Our Razer Blade 18 is 147 FPS average with 97 FPS for our 1% lows versus a desktop class 5090 in our two other systems at 1080p. It's surprisingly close. 1440p, the Razer Blades 5090, you start to see that's like, wait a minute, they've tuned the 5090 to run in a laptop. Because remember, the desktop 5090 is 600 watts. In this laptop configuration, it's puttering around 150 to 200 watts most of the time. And 200 watts is really kind of an overestimate. So this is remarkable performance per watt. 2160p, 47 FPS. Deus Ex Mankind Divided. I like to use that one because there's some odd things in the engine, and it's nice to get it sort of a baseline. 192 FPS at 1080p. 169 FPS at 1440. and 91 FPS at 4K. Dawn Trail, Final Fantasy Dawn Trail. At Razer Blades 224 FPS, which is, again, very close to our desktop counterparts at 1080p. At 1440p, the gap widens a bit, 175 FPS versus 261. But are you really going to be that upset if you're playing Final Fantasy Dawn Trail at 1440p on a portable machine? I mean, come on. And the 2160p still manages 90 FPS. So, not bad. Shadow of the Tomb Raider. I always like to test that one, even though it's ancient. 227 FPS versus 286 and 280 on our desktop counterparts. This is basically the same class of performance. Now remember, on our desktop machines, when we step from 1080 to 1440, in this particular game, there's really not a lot of performance difference. Here we do have a little bit more performance fall off from 1080p to 1440p. But remember, you can run the display here, full HD, 480 Hz. At 2160p, 119 FPS, 244, 249. Again, this is fantastically good for a portable machine, a luggable laptop. Monster Hunter Wilds, 1080p, 97 FPS. At 1440p, 84 FPS. And 4K is still 56 FPS. And if you were willing to use this is Ultra. If you were willing to use some upscaling technologies, you could definitely play over 60 FPS at 4K. But I think 1440p is probably the sweet spot. Or if you're using, 1440p natively scaled to the nice not 16 by 9 aspect ratio display, 90 FPS you can target in just about every AAA game, and this thing will deliver. So what about battery life? This has a 99 watt-hour battery life to come in just under the limit for an airline. Actually, I think an airline would have a little trouble stuffing this in their fire retardant buckets. They have special, oops, my laptop is on fire response kits, and it involves putting the laptop in a thing to help seal the fire or do away with the fire. And I don't know, 18 inches, but 99, the wattage is fine. I was getting about 5 hours to 5.5 hours in Windows with web browsing and light web browsing type tasks and streaming movies. So that is actually a much higher result than I was expecting. Most of the time, my experience with laptops like these is the battery lasts like an hour or two. And 5 is pretty good. Now, if you're playing a game or something like that, your battery life is going to be down around like an hour because 99 watt hours. And the performance will also be reduced because when we did our testing here, it was plugged into the wall. And when it was plugged into the wall, our kilowatt meter bounced between 200 and 250 watts for most of the benchmarking and most of the testing that was going on. That's pretty good, 200 watts, but 99 watt hours, 200 watts, it's going to be dead in less than an hour when you're playing a really demanding game. The reality was that somehow I was able to get closer to 2, so there's some power saving stuff going on there. And I didn't really notice the frame rate dips or anything like that. I wasn't looking for it, but playing Cyberpunk for over an hour before the battery died was a reasonable actual gameplay experience. So, it's fine. Truly 240 FPS on the display? Well, I like to measure how long it actually takes the pixels to respond for 240 hertz. And at 240 hertz, we would expect a frame refresh in about 4 milliseconds, give or take. 250 FPS, 4 milliseconds per frame on average. That would fit into just about 1 second. But we can see on our high-speed photography, where we've got 1/1300th of a second shutter speed, that it takes a little bit longer than that for this panel to actually update. You can see that we have several cases of more than one square being on at any given time. It seems like this panel's actual pixel response time from kind of a lot of gray to kind of a lot of other gray. It's definitely an official measurement expectation thing because gray to gray, it can start showing differences really quickly, but when does it mostly change? And that's on the order of about 8 milliseconds, give or take. That's not bad. That means that 120 hertz on this panel is entirely reasonable. And my experience with that is, the panel is really nice. And at over 100 hertz on a laptop, that's pretty good. In terms of video games, when you're playing video games with motion blur or anything like that, sweeping the camera from side to side, will the display keep up with a lot of motion, like a real-time strategy game or a top-down game where you're moving the map around? Yes, better than most laptops. Nearly every laptop would be inferior to the experience here. Still, I don't think the panel's fast enough for 400 hertz to make sense. But if you're a professional gamer and you have a different opinion, that'd be interesting. Love to hear from you. because think about 160 hertz is the sweet spot for this panel, IMHO, in terms of how fast it can actually respond. Now, it'll accept a high refresh rate signal, sure, but just say it. I've loaded LM Studio on Windows here, and we're loading the Quen 3.6 35 billion A35B in Q8. So this is the 8-bit model. Now that is a little too large to fit in our 24 gigs of VRAM. It's going to spill over into RAM, but the performance for something like this is quite good. And that is one reason why you might want 64 or 96, or maybe even go off script and get 128 gigs of memory, because you can use a mix of those things if you're doing this kind of development. And so they sort of figure that, hey, maybe people will be doing that. This comes with Windows Home. It really should come with Windows Pro. When you're going to be spending this much on a laptop, immediately having to upgrade it out of the box to Windows Pro. And for retail prices, like Microsoft charges you and me a lot more money for Windows Pro than they charge somebody like Razer. So if you have the option when you're buying this to get Windows Pro, get Windows Pro. Don't bother with Home. The other thing is that when you're doing this kind of work on this kind of a machine for a prolonged period of time, it's going to run hot and it's going to make a lot of fan noise. The fan noise on this thing is audible. It has 2 big fans and 1 little fan. And you can see that when we take the bottom off and you look at the upgradability. It is upgradable because it has 2 DDR5 sodium slots, which is great, but it wasn't really like vapor chamber design and all this other kind of stuff. I would argue that this kind of a form factor is not really designed to be on 24/7 doing, fine-tuning workloads and like truly pro workloads. But if you need portability and you need this much horsepower, there's literally no other option. And this is actually probably your best option because the keyboard is nice, the display is nice, the trackpad is probably the best trackpad for Windows that I've used, probably owing to its giant size. It's just very easy and comfy to use. It's very fast and responsive. We did Steve from Gamers Nexus was here and he had a laptop that had a malfunctioning trackpad. And that reminded me how bad trackpads could be. This trackpad is actually pretty delightful. Razer's also put some work into the RGBness of the keyboard. So like when you press shift, the keyboard changes the labels that are lit up. So there's a lot of stuff that goes into that. You can get an extra 17 minutes of battery power if you turn off all of the RGB stuff when you're doing the 5-hour runtime. Just FYI. So you can see here with our 35 billion parameter model loaded, I'm using 30 of my 31.4 gigabytes of memory in this configuration. 56% of our Intel graphics card is being used and 23% of our 5090 is being used. And still, it's running pretty quickly. I asked it to write a Python program to search for perfect numbers. And this is a pretty good test for reasons that I've explained before. You can see it going to town. I don't know if you can pick this up on the microphone, but the fans have started to ramp. And we are currently consuming 236 watts, which is about what it does when it's gaming as well, like 230-ish watts. It sort of hovers around there. It depends. The other thing I was slightly surprised by was our disk configuration in here. It's not PCIe Gen 5, it's PCIe Gen 4. It is nice having PCIe Gen 5 to be able to load models really quickly, but the M.2 that they've chosen here is probably cost and power optimization, so that some of those PCIe Gen 5 SSDs have kind of a high idle power, and so that would probably negatively impact the battery. So I kind of get why, and then, also macroeconomic conditions. So I also get why maybe they would go for a PCIe Gen 4 SSD, but it is upgradable and expandable. I mean, check out the bottom. You can go nuts. You can add more storage, whatever you want to do. Our storage is a Samsung MZV82TO HBL1. This Core Ultra 9 290HX Plus is really holding its own in this workload. Like, you got to give it to Intel. The generation of CPUs that we're on, desktop and mobile, Intel has really put a lot of work into power efficiency and like the power efficiency consideration. So as much CPU as this is using, most of our power budget is going not the CPU, which is nice to see. And this Core Ultra 9, 290HX Plus, it's 24 cores and 24 threads. It is going toe to toe with desktop parts that have a higher power budget. That also tells you how little you get from adding the extra power budget on a desktop class CPU. You could run it at a much lower wattage to have basically the same performance. We saw that in the benchmarks, but we're also experiencing it on the laptop itself. All right, so even after this relatively long output of 4 kilotokens, we're still running an average of 17.79 tokens per second, which is really good considering that our model spills over into system memory. Now, if we run a model that fits entirely in 24 gigs of VRAM, the 5090 really does shine because it's a laptop 5090, and even though it's a relatively low wattage, it's very efficient for those kinds of tasks. So if you have a model that fits in 24 gigs of VRAM, you're going to get 40, 50 tokens per second plus, no problem. So here we'll load Gemma 4, which is a 7 billion parameter model at Q4, and it's only going to take 12 gigs of VRAM. And we're going to up our context length to 128K, basically, 131,072. And then we're going to ask it to regenerate this once the model has loaded. And so this model is much smaller. It's going to produce a different output. But I'm surprised that even the smaller models now think about constraints and practicality and helper functions and, you know, Euclid's formula, Euclid-Euler. Like this model, it's unthinkable that a model this small would consider a result this complicated even just a couple of years ago, because you can search for perfect numbers in like 6 lines of Python. And so this is quite good for a small model. But yeah, this is running at 110 tokens per second, which is about what you'd expect for this kind of model running entirely from VRAM on a portable machine. And it also only required about 12 or 13 gigs of VRAM. Also, I want to point out, because I experimented with and messed with the memory configuration on this, the out-of-the-box configuration for me was 6400 mega transfers. I think some of the other configurations for this laptop probably run at 5600 from just playing around with the web configurator. My 128 gig kit was 5600 natively, but I also have some 7200 mega transfer memory, and the compatibility, like the laptop worked across a wide range of DIMMs that I tried on it, which was very nice to see. But the out-of-the-box configuration, 6400, and that gives you a little bit of a speed bump when you're doing really memory-intensive things. But I would have liked, to see better than 100 nanoseconds. All right, now let's talk Thunderbolt 5. You might have noticed that I've already got our Thunderbolt 5 Core X enclosure here on the desk. Let's go back in time and talk about how we got here. Razer also makes a Thunderbolt 5 dock. Now, wait a minute, you might be saying, why would we need a Thunderbolt 5 dock? It has a 5090 in it already. It's because we're putting an RTX 6000 in it. It's a Razer Core X V2. This dock is enormous. It does not come with a power supply. You have to supply your own power supply that's appropriate for your GPU. If you have a lesser laptop or a laptop that doesn't have a built-in GPU, then you would be fine with like a 5060 Ti or a 5070 or a 9060 or a 9070. For me, we test all the mini PCs and all the things, and this is the perfect thing for me to test that because this is such an overkill dock. And it's room for a 4-slot GPU, but it's very light. Also, there's no extra fans in it. Very slight damage in shipping. Yeah, so there's not a lot going on in here. You get the one fan, room for your power supply plugs in here. You get your PCB, your Thunderbolt connection is there. That's it. I would call this a cost-optimized design, but this looks like a perfectly reasonable approach to a Thunderbolt 5 enclosure. You literally just have the Thunderbolt 5 interface on the back, and it goes direct to the PCIe. Thunderbolt 5 is 80 gigabits both ways. That's double the bandwidth of Thunderbolt 4 and double the bandwidth of Thunderbolt 3. It's 4 lanes. You can run Thunderbolt 5 in a mode where it's 120 gigabit one way and 40 gigabit the other way, the same speed as Thunderbolt 4. It depends on what you're doing. If you have an external GPU with a monitor hooked up to it, 120/40 can make sense. For a lot of our testing, I think it's going to be 80/80. But this is something that you can configure at the chipset level. You don't have to do anything here on the inside in order to make your choice. All right, let's get a GPU and a power supply put in this and get it hooked up and see what it does. I get my power supply mounted, 850 watts. All that power budget is going to go to the GPU. It uses the motherboard connector and the motherboard CPU connector. It doesn't take one of the PCIe connectors for going in. So you make sure that you use the CPU power connector and not a GPU power connector connecting to the little tiny PCB in the bottom of this thing. Now, one place I think Razer missed out on here is they should have had reverse mounting for the power supply so that you could mount the power supply either way. All your power supply mounting is going to be flow through here. So it's going to pull air in from here and exhaust it out the back. If you have a double flow through GPU, it's going to be just hitting the power supply. If the power supply were mounted the other way, there would be an airflow path for the warm air to come in through the power supply and exhaust out the back. I think that would probably be a better design. Of course, the other option, because you only need a maximum of like 650 watts, would be to use an SFX power supply. An SFX power supply sometimes will come with a mounting bracket. So look in the description of your SFX power supply and see if it comes with an SFX to ATX adapter bracket. If not, you can order those separately. They're typically just a few bucks. But I would really recommend an SFX power supply, not a full-size ATX power supply, if for no other reason than airflow, especially if you're going to go for a double flow-through design. Even if you're not going to go for a double flow-through design, having airflow on the back of the card, which typically gets hot anyway, fantastic. Because remember, you've only got the one fan here, and the airflow design of the case is really not such that the airflow from the one fan that you have is directed to any particular part of your GPU. Dang it, it's Thunderbolt 5. We want to go fast. Okay, so the way we pre-flight check the Core X2 is my handy dandy GPD-Win Linux laptop. It's Thunderbolt 4 instead of 5. But the reason for this is because there's kind of a lot of arcana around Thunderbolt and PCIe resource allocation and conflict and bar space and everything like that, especially when you're rocking a 96 gig RTX 6000. It's an unusual setup. I mean, like I was saying, why would you have an external 5090 when you have an internal 5090? Well, the reason is 30 gigs VRAM, and the internal or the external 5090 would be quite a bit faster than the internal 5090. But as a platform in general for non-Razer products and everything else like that, I sort of put it through the paces. In fact, Level 1 Tech Center Forum is probably the best place on the internet, or one of the best places on the internet, for all things Thunderbolt Arcana, because it's hard. We were the ones that found the bugs in Threadripper motherboards, where if you have a 48 gig GPU and Thunderbolt enabled on an Asus motherboard, it might not post. Or if it does post, the Thunderbolt ports don't work. Anyway, I digress. This is a great platform and a great revision of our Thunderbolt 5 chipset, because there were a couple of other earlier revisions or configurations. It does show up as the Core X. It does work with authorization, security, DMA, pre-boot DMA. These are all other variables. Doesn't really matter for this video. The I's have been dotted and the T's have been crossed on those very important details with this particular external enclosure, which is great to see. Now, let's get back to our regularly scheduled giant 18-inch laptop testing. 24 gigs of VRAM is not enough. Let's go for 88 gigs of VRAM or 112 gigs of VRAM, 96 plus 24. Look in Task Manager. We now have GPU 0, 1, and 2. Our RTX A6000 is going to do some heavy lifting for us as we load our 35 billion parameter Qwen 3.6, which is a wonderful model, by the way. So as you can see, it is dramatically, breathtakingly faster. And it doesn't matter a ton that the interface is only Thunderbolt 5. I mean, to be sure, in 2026, Thunderbolt 5 is not nearly enough bandwidth. I mean, Thunderbolt 4, when it was released, was a lot of bandwidth, and then it stopped being a lot of bandwidth about 3 years later, and then we continue to have it for like 10 more years. So we need to be moving on to Thunderbolt 6 at this point, or Thunderbolt 7, or something. But it's fast enough, especially because of our mixture of experts model, that this is dramatically, breathtakingly faster than it was previously when we were using a combination of the 5090 and it was spilling over into the system memory. 95 tokens per second versus 17. I think we're doing okay. That's crazy. Now, as for the 5090 power, I understood that the 5090, the laptop version of the 5090, was supposed to be power gated around 160 watts. And it does seem to level off at 160 watts a lot of the time, but it also seems to be able to consume more power than that. Or maybe I don't have a good picture of the power usage between the CPU and the GPU, because like I say, at the wall, you know, we're 230 to 280 watts, spiking above 300 watts sometimes. But I would think that the 5090 laptop edition is going to be limited to 160 watts, even as we're letting this thing run overnight and we're letting our GPU temperature ramp up. The temperatures on the GPU side of things generally stayed under 70. And it does seem like the system knows when its external temperature is around that 100 degrees Fahrenheit mark, give or take, because you can see a little bit of a performance fall off when you do that. But when we're running Cinebench or something that is CPU oriented, this has no problem cooling the CPU workload even for hours. Like the Cinebench workload did not change no matter how many hours of Cinebench testing we ran. It was only when we were really stressing both the CPU and the GPU. And to be clear, gaming and most kinds of AI workloads don't really do that much stress. Fine-tuning and like training, if you were training a small model, are definitely more stress. Blender rendering, if it's using the GPU and the CPU at the same time, maybe. But generally, you're using one or the other, and not both at the same time. Well, both at the same time to 100% of load. Okay, so what's the bottom line? If an 18-inch laptop that weighs 7 pounds, plus a giant 400-watt brick, is not off-putting to you, or you really want a 24 gig VRAM portable monster, there really isn't anything comparable to this. It keeps up with gaming. It has surprisingly good battery life. The keyboard is really comfortable. It's like 1.5 millimeters of travel. The touchpad is easily the best touchpad on any Windows machine that I've ever used, probably owing to its giant size. It's very, very easy to use. Has a satisfying click. It's very responsive. No problems there. Serviceability. It's pretty serviceable for cleaning the fans, which will be important because they will run a lot if you actually use this thing as a daily driver and really put it under a lot of load all the time. The RAM is upgradable for whenever RAM is affordable again, hopefully long before this thing is obsolete. I don't want to think about a world where the RAM is not affordably upgradable after this kind of a laptop is obsolete, because it's an absurdly high-end laptop. I would have liked to have seen built-in like 5 or 10 gigabit Ethernet. The built-in 2.5 gig wired Ethernet, but then wired on a laptop is kind of unusual, so like maybe. And 10 gigabit USB-C adapters are now also a thing. I don't know. One of the most delightful aspects of this laptop is definitely that Intel is... there are signs that Intel is recovering. Intel is healing because the CPU and the power utilization and those aspects of the laptop are quite good. At the same time, it's kind of impressive what NVIDIA has managed to pull out in a 160 watt portable 5090, because that's even below the wattage of like the enterprise class versions of that GPU. 24 gigs of VRAM is also a power budget thing. It's like, why not 32? It's like, well, 24 is already putting quite a dent in your battery. You don't realize. So for a certain kind of person where money is no object, this is probably a great option because it's well built and it's well put together and it was a fun thing to use. But now I need to pack it back up and send it back. So I'm going to this is level 1. If you have any questions or I miss anything about the Razer 18 laptop, or if you're experiencing problems with it, we have a user forum where you can get some feedback from people that have it and people that don't. So like if you want to post your own unboxing pictures and things like that, that's why we have a forum. So join us. Be more awesome with all of us. None of us is as dumb as all of us. No, that's not right. We can together protect ourselves in our uncertain future of crazy. I don't know. I'm Windows Level 1. I'm signing out. You can find me in the Level 1 forums where we discuss such things and, the unholy Thunderbolt 5 stuff. Because that's just what we do. All right, I'm signing out and I'll see you there.